Well, good morning. This is Tuesday morning, the 5th of September, 2017, 11:03. I waited till a few minutes to see if anyone was coming in. It's supposed to be Math 237 linear algebra, but I'm the only one in the class right now, so I'll just get going from here. I do have a few announcements for you, okay? Three major ones here. Let me hit these first. First, let me just tell you what I have or haven't done. Over the weekend, Friday, I had a decent time getting things done during my office hours Friday. Not as much as I would have liked. It turned out that neither my boss or his secretary were there, so I was the only one in the office on Friday, so if anything came through, I had to deal with it. And not that much happened, but a few things did do. For instance, the dean came by and she wanted to chat for a while. She wanted to see him. He wasn't in, so she chatted with me. So that took longer than I had anticipated. But, and then too, I was making good progress on getting things updated in blackboards and, things like that done. But the place where my office is over there, usually first thing in the morning when not many people are on the system, I can get things done pretty easily. But then after a while, I don't know what it is. I guess it's that I'm the last person on the node over there is how I look at it. That may not be the correct way to look at it in computer science. And when too many people get on the system, it just slows down so badly I can hardly get anything done. And so Friday, actually, I had to finally stop and go to the STEM lab and work on a computer in there that was hardwired in and not doing the Wi-Fi, because I just couldn't get the Wi-Fi to work fast enough to get anything done. I would have it doing something and then it would time out and shut down. I'd have to get back started, try it again, it would time out and shut down. So I finally just went to the other room. So bottom line of all that, I don't think I got all of your Blackboard updated and done yet. I'll have to go back and check. I was doing things all weekend, and when I could, sometimes I could get on Wi-Fi and sometimes I couldn't, and various things. So I can't remember. These smaller classes like this one, the higher number classes, I typically did not get those things completed. I'll have to check and see. I know I got some things done on it, but I can't remember if I got your Blackboard updated or not. So, sorry about that. Hopefully not today, because I don't have any office hours today, but tomorrow afternoon after 3:15, hopefully I'll have some time to finish updating Blackboard and that type of thing. All right, that's announcement one. Announcement two. I'm hoping it will not interfere with this class any, but next Tuesday, 1 week from today, I have a doctor's appointment. I think I told you all at the first of the term I have a mild form of leukemia, but I have to see my hematologist every few months, and he only sees patients on Tuesday mornings. So next Tuesday morning is my time. Hopefully it'll be the only time this term I have to see him, but if I have to see him, and the appointment's at 10 o'clock next Tuesday morning. Now, I have to be there 9 o'clock to have labs done, and so if I were to come out here Tuesday morning, I could get here at 7:45, but then have to leave at 8:15 to get back to the Clarkson Clinic and get parked and everything so I could get the blood work done by 9 o'clock. So I'm not even going to come out. It just isn't worthwhile to come out for 15 minutes of class and then turn around and go back. So I've already worked that out with my 8 o'clock class. I've already worked it out with my 9:30 class. Now my actual appointment is at 10. If he can see me at 10 o'clock and say we finish by 10:15, I might be able to leave the clinic by 10:15, and so I could be here by 11. Okay? However, there's a real good chance I will not be here right at 11. Usually by those late morning class appointments, if he's gotten delayed in the earlier one, then all the rest get delayed. But try to be here by 11 next Tuesday. Thursday, I'll be here on time. But next Tuesday, try to be here by 11. I'll get here as soon as I can. We'll try to get as much class in as possible. I don't know if there'll be an opportunity to make up that time because I only have an hour for lunch, and then I have a class starting at 1:15. So there's very little time to make it up. So I will be here definitely next Thursday, starting on time. But next Tuesday, I may not be here right at 11, but I will be here, and I will get started as soon as I get here. So please be here. Now, I think I botched something up. Oh, the third announcement. We are starting back the math teams, okay? Now, our last year was the first year we ever had a math team, and we did remarkably well for it being our first time. It was a lot of fun. The kids that participated, the students that participated, I think they learned a lot and they got a lot done. So I highly encourage you, if you can, to participate and consider it. So I just had the first student come in. And I don't have the right roll here. Here it is. Okay. Jasmine is here. This is the 5th, is it? Yeah, 5th of September. Okay, and Jasmine's here. All right, okay. I'll try to do these more quickly than I did. I started with the announcements. Got 3 major announcements, okay? Number 1, I worked toward it, but I can't remember how far I got to getting your Blackboard updated. Friday, I was the only person in the office, so any student came in, any faculty member, any staff member, administrator came in, I had to deal with them. I did get a lot of work done. I don't think I got as far as this class though, okay, as far as Blackboard and stuff. So I also worked on it over the weekend when I was home, but you know, we had plenty of other things going on as well, so I can't remember what I got done and what I didn't. I've got to sit down with it starting from scratch and go back and review everything. I know I got Math 112 class completely done, Math 113 class completely done. I got my afternoon class, Physical Science 111, partially done but not completely done. I got my Math 100 class completely done. It's the smaller math classes, 126. I think I got 126 and 227 both done too. It's the 237 and 238. I can't remember how far I got. And I don't think I got either one of them completely finished. So, and I didn't get completely finished on the other 2 small math classes. So it's, I've got and I won't have a chance. I'll have sometime maybe this evening, but the biggest chunk of office hours I have are tomorrow afternoon, 3:15 to 5:15. So hopefully by then I'll be able to get things caught up. So by Thursday, knock on wood, I hope they will be there. I can't swear to it because anything could happen tomorrow afternoon too. All right, that's number 1. Number 2, next Tuesday, I have a doctor's appointment at 10 o'clock. I don't know if he sees me at 10 and we're through by 10:15, I could be back here at 11, okay? The likelihood, I'll be there at 10, knock on wood, I'll be there at 10. Whether he sees me at 10 and whether he can finish in 15 minutes, that's the unknown, okay? So there's a good chance I won't be here right at 11, but I'll be here soon after 11. Now, the exception to that would be if he gets way behind in his 8 o'clock and 8:20. I mean, he has appointments every 20 minutes, I think. If he gets way behind in the morning, then who knows when I'll get here. But the odds are, usually he's pretty good about seeing me. he only sees patients on Tuesday mornings. I had no choice. They didn't give me an option. I usually either ask for the first one of the morning or the last one of the morning. They gave me the one smack in the middle. Okay, so I'm losing my first and second classes because I have to be there at 9 for labs. So if I came to campus, I'd have to leave by 8:15 to get back there by 9. So I've already made arrangements for the first 2 classes, but this class, I hope to be here. I may be late, but I hope to be here. Thursday, I'll be here on time, knock on wood. But Tuesday, I may be a few minutes late, but I'll get here as soon as I can, and we'll try not to have to make much up. We'll see. Okay. That was the second announcement. Yeah. The third announcement is Mr. Racy. Do you know her on the Birmingham campus? Okay. She is the official coach of the math team, and they are reforming the math team this year. They have a competition coming up early in October. I think it's the first Friday in October, or maybe the second Friday, but it's early in October, and they're trying to formulate the team now. Y'all are prime candidates for this because you've had all of your low-level math and you're into your higher-level math. If you could possibly do it, she would love to have you on the team. What is fun, it's no pressure, it's not a negative thing at all. You get to travel the only meet I know about right now is at Shelton in October, and it's going to be on a Friday, so it doesn't interfere with classes. At least that's the last I heard. So, and last year the team had a great time together. Actually, you learn a lot of math, but it's no pressure. It's just fun, you know. So if you're at all interested, she would love you to be participating. You can either contact her directly or you can let me know and I will pass it on to her. Her email address, I'm going to write it down here, is N. Jaracy, Jaraysy, at Lawson State. I can't spell. .edu. I can't write well either. Okay. Let me clean that up just a little bit. What's that? Yeah, and I mean, she can take as many people as will come. The more the merrier. And she will be having some practices on the Birmingham campus, and she said she could come to the Bessemer campus certain afternoons and have practices here. I'm available for practice. We did it last year on this campus. I did most of those. I'm here. I can have them Monday and Wednesday afternoon between 3:15 and 5:15. So as much or as little, 45 minutes, an hour, 2 hours, whatever, you know, I can do. But that's the only chunk of time I have on this campus for office to do something like this. All the rest of my time is I'm in class, so I'll be glad to work with anyone that wants to participate Monday, Wednesday, 3:15 to 5:15, anytime in that time frame that you would like. Or she will come out days when she's free, and she'll let you know if you email her. Or if you're on the Birmingham campus, she will work out times that she can practice, have practice times there too. What we do, we work through problems that they used on previous competitions, and it's really fun. It's a lot of good time. Okay, you would like to do it? All right. Okay, I will pass your name to her, and she'll probably be in touch with you. When is a convenient time for practices and things like that for you?
Probably like
When?
Monday and
Monday and Wednesday? Is the 3:15 to 5:15 good? Oh, okay. Then we can do it, yeah.
Friday in her work, but if she just knows like the days and the tournaments, I can
Yeah.
just let my job.
Right. Yeah, well, she can let you know that. I'm pretty sure it's either the first or second Friday in October. I saw the date, and it was early in the month. I just don't remember if it was the 9th, if it was the, I don't even know what the Fridays are, like the 5th or something like that, or if it's the 9th or 12th. But it was someday early in the month. I know it's on a Friday, so, and it's going to be at Shelton in Tuscaloosa. Okay. So, but you can, if you'll get in touch with her, she'll let you know exactly when that is. When do you want to start practicing? Tomorrow or any other time? Huh?
After calculus on Mondays, I have a break into my physics class at 4:45.
4:45. So you could do 3:15 to 4:45 or something like that. Okay. Now it probably wouldn't be in this room. We could be in the next room, 257, because Dr. Bryant teaches physics in here. You know, your class. He teaches one before that too. So we could probably move over there, and I'll record them on Screencast-O-Matic and put them on YouTube, just like the others. In fact, I imagine the old review sessions are on there too, so you can listen to any of those if you want to too. You may even see some of the same problems being done again. So they'll be there. I'll give you the link when we start the practice, but you can look it up, and it's called Math Team, I think, or something like that. Okay. All right, good deal. I know she'll be pleased to hear that. All right. Now, the lights to those ones in the room with me. The light and all that. Okay. I'm going to clear this off the screen now. And you'll have to remind me, I think I went to erase, but my eraser didn't work very well, so I have 2 marks on the page. Yeah, we did example 6 last time, didn't we? What's that? Gauss-Jordan. That's where we're starting. That's what I thought we were. Example 7. With Gaussian elimination, you apply the elementary row operations to obtain a row equivalent matrix that is row echelon form, which, of course, here's a review. The first non-zero entry in the first row is a 1, zeros below it. First non-zero entry in every row is a 1 with zeros below it. And those leading ones, that's what we call them, they go top to bottom, left to right. So you don't ever have a 1 in the row that the previous row had zeros in it. You always do that leading 1 with the bent to the right as you go down. Okay. Now, a second method of elimination called Gauss-Jordan elimination. Well, with the Gaussian elimination, remember, you always had to goodness gracious, what is the term? Oh, goodness, what is that term when you do it backwards? Back substitution. I couldn't remember substitution. I was going to say transfer. That wasn't it. Back substitution. In Gauss-Jordan elimination, you eliminate the back substitution. You get as far as you can go, and the only difference is, once you have a leading 1 in any of the rows, not only do you get zeros below it, but if you have any equations above it, or rows above it, you get zeros there too. Okay? And that eliminates the back substitution for you. So here is a system of equation. I think we may have already worked it, but let's do it. X minus 2y plus 3z is equal to 9. Minus x plus 3y is equal to negative 4. And 2x minus 5y plus 5z is equal to 17. Yeah, I'm pretty sure we've done this one before. What would be your first step? Your augmented matrix. And what would that be? Right. Okay. And you start it just like you did before. What feature do you want to be first? First non-zero entry in the first row to be a 1. We got it. Good. What do you want to happen next? Yeah, you want zeros below it. So let's start with the second one. How do we get that second one, that negative 1, to become a 0? We're going to use the first row to write it down. 1, negative 2, 3, 9. You use the rows with the leading 1s. That's what we're using. And what do we do to get a 0 in the second row? Yes, row 1 plus row 2. That gives you this. And what do you get there? 0, 1, 3, and 5. Okay? What's the next thing you want to happen? Okay, you will want that to happen, but actually, let's finish what we got here. We got a 0 below that. You want a 0 here too. Yeah, you don't have a 1 there. That's going to come up next. But let's do this one now. We want that to be a 0. The 2 to be a 0. How do we make that happen? Negative 2. So negative 2, row 1, plus row 3. That should do it for us. And what would that give us? 0. No, you're right. Negative 1. Negative 1 again. Negative 1 again. You're stuck on negative 1s, aren't you? Okay. And what's the next thing you want to happen? The first non-zero entry in the second row would be a 1. We got it without doing anything. Now with Gauss-Jordan elimination, we want the negative 2 to become a 0 as well as a negative 1. So this is the difference. Before, we just got one and negative 1 becomes 0. That's pretty easy. Now we want the above and below your leading 1s to be 0s. So how do we get that to happen? Using the second row, those leading 1s, we'll just, let's just do one at a time. Let's do that, negative 2. Okay. 2, row 2, plus row 1 is the new row 1. Okay? So let's get that one. What does that? We're using the second row, so I'll write it down. 0, 1, 3, and 5. Okay? And then 2 times 0 is, plus 1 is 1. So you see, once you get it set up, you don't ever change those leading 1s because those zeros. Okay? Next. 0. Next. Yeah. 2 times row 2 plus, that'll be a 9, yeah? 19. Boy, big numbers here. Okay, next. Right. And how do we get that to be a 0? Yeah. Row 2 plus row 3. Okay. And that would give you 0. Good. We didn't want that to change. 0. Say again? Okay. Let me make sure I know where you are. Add those two together. 2 and 4. Okay. Now, what do we want to happen next? Let's see what we got so far. First non-zero entry, row 1 is a 1, 0 is below it. First non-zero entry, row 2 is a 1, 0 above and below it. Next thing we want is that to be a 1. How do we get that to be a 1? Divide by 2. So, if it's okay, I'm just going to divide by 2. Okay? I'm just going to write it that way. That becomes a 1, that becomes a 2. Is that all right? Just to keep from writing everything down again. So what's the next thing you want to happen? Yes, so you want the 9 to become a 0 and the 3. Let's do the 9 first. How do we get that to be a 0? We're using the third row. Yeah. Say again? Negative 9, row 3, plus row 1. That should do it. We're using the bottom, so that's 0, 0, 1, 2. Okay? And the new top row would then be 1, 0, 0. Second? 1. Okay, good deal. What do we want to happen to the next? 3 becomes a 0. Using the third row, how do we make that happen? Second? Right. Use those leading ones. Yeah? Negative 3, yeah. Negative 3, row 3, plus row 2. Okay? And what does that give us? 0 and 1, right? Okay. 0, negative 1. Okay. All right, here's, gotta find the roll here. Here it is. All right, Kimmel. Now, a little bit of time out here. I announced it before Jasmine came in, and after she came in, I'll do it again. So it'll be 3 times on here. 3 sort of important announcements you need to know about. First, I made good progress Friday and over the weekend to get Blackboard caught up, but the 2 classes I'm not sure that I got everything done are this one and my differential equations, my 2 highest level math classes that are very low numbers, because I tried to get the big classes done first. I didn't get all of them done, but at least I got progress made on them. I had difficulties. Friday I was the only person in the office, so anyone who came by I had to deal with, and all the other really sad songs I could sing to you on that. But then over the weekend we had lots of things going on, and so whenever I had a chance I got things done. But in between, I had a real good system going on Friday, but I ran out of time. Well, and also I had another issue. The place where I work on Friday in my office over there It's a little room off my boss's office, and we're in the corner of the building, kind of. Well, when too many people get on the system, on the wireless system, that's what I got. My laptop is wireless. It usually will get so I just can't do anything. Everything takes so long, and I was trying to update Blackboard and stuff, and things would just grind away, and finally it would time out. So it was so frustrating. So I finally moved to a lab where I could do a hardwire computer and got more things done. But that killed some time there too. But anyway, all that sad story over with. I don't think I got this class finished. So hopefully, I may have a little time this evening. I don't know that I will, but I might have some time this evening. I don't get home till late today. I might have some time to get it done, but if not, it'll be tomorrow afternoon, 3:15 to 5:15 is my only office hours to get things done. So hopefully I'll have it done before Thursday. Okay. Now there's a little caveat there too, so hang on to that. Number 2, next Tuesday, 1 week from today, I have a doctor's appointment at 10 o'clock. Okay? If he sees me at 10 and I can get out of there by 10:15, which that's pushing it, but if I can get out by 10:15, I should be back here on campus by 11 for class to start. But if he's running late or checkout takes too long or anything like that could happen, I might be a little late getting here, but I will be here. So if I'm not here at 11, stay. Stay here. I'll get here as soon as I can. Now, if it looks like he gets really bogged down and I'm not going to make it, I will call somebody and have them come up and put a note on the board. So unless you hear otherwise, I'll be here next Tuesday. I may be a few minutes late, but I shouldn't be too late. Okay, it wiped out my first 2 classes, but it won't wipe out this one. And number 3, do you know Miss Nyla Geraci on the Birmingham campus? She's a math instructor. She is the math team coach that all of us help with it. And we're trying to get the math team reformulated because the first competition is early October. So if you think you might be able to participate in it, please let her know. Do you think right now that you would be able to? It's a lot of fun. It's no pressure. It's just fun. Yay or nay?
No, sir.
Don't think so. Okay. Jasmine is going to try, so I thought. But anyway, I'll tell her Jasmine, but I won't mention yours. Okay. Now, that could also, because I think we already decided to start Wednesday, to start having our practice from 3:15 to 4:45. Is that what you said? Or 4:30? What?
Well, my class starts at
4:45. Okay. So we're going to start having, if you do want to come by Monday, Wednesday afternoon, around 3:15 until 4:45 or so, we'll start having practice. Now, I don't know if I'll have the questions by then, but I'll contact her and I'll see if she can get me questions. What we do is use questions they've used before in the math competitions to practice on. Okay. We had just finished solving or converted this system of equations to an augmented matrix, reduced this, but what we did was now, before we did Gauss-Jordan elimination, which is getting leading ones and putting zeros below it. That was Gaussian elimination. What we're doing now is Gauss-Jordan elimination, which for every leading one we get 0 above and below it. And what can we do then? We can read off our answers with no back substitution to speak of. This says that x is equal to 1. This one says that y is equal to minus 1. And this one says that z is equal to 2. And I think if you go back to example 3, you'll see that's the same example we did by row operations, and doing back substitution, we got exactly the same answer here. The beauty of Gauss-Jordan is you don't have to do back substitution or minimize back substitution. You read off your answers. So what was it? It was one step here more to do, and that was a pretty easy step. And then 2 steps here, which were pretty easy. And then you can just read off your answers. So
the ones on the end equal x1.
Yeah, those are, remember, your columns represent the variables or that constant. That's the augmented part. So this represents your x equal 1, y equal -1, z equal 2. That's how we did up here, only put all the coefficients in, but what we did on the augmented part was our constant. And that's what you wind up with. So no back substitution, pretty easy, pretty nice.
So the only difference between the first row echelon is you do that substitution.
Yeah, and this actually is called reduced row echelon. When it was just the zeros down here, that was row echelon form. If you have zeros down here and zeros up here, then that's called reduced row echelon form. The other was Gaussian elimination. This is Gauss-Jordan elimination. Okay. The Gaussian elimination required back substitution. Gauss-Jordan elimination minimizes the amount of back substitution. Okay. There's a little remark at the bottom of the page, and I was just about to skip over it thinking that was all part of example 7, but it isn't. This elimination, both of these elimination procedures that we've talked about, sometimes result in fractional coefficients. Okay? If you had a system of equations that did not have a 1 at the beginning, or a 1 in some one of those first terms, either plus or minus 1, and then the first thing you've got to do is divide by whatever the coefficient is. That could result in fractional coefficients. If you have those, it's not bad. I mean, it's a little messier, but you can do it. Okay? No matter which order you choose, the reduced row echelon form will be the same. And that's the key to it, whether you have fractional coefficients or whatever. Now they have these little discovery boxes here. And neither of you have your books here, do you? So let me just do this. This is, we're going to be doing this kind of stuff later, but let's do it now. It says, without doing any row operations, explain why the following system of equations is consistent. Okay? 2x1 plus 3x2 plus 5x3 is equal to 0. This is the top of page 20. Minus 5x1 plus 6x2 minus 17x3 is equal to 0. And 7x1 minus 4x2 plus 3x3 is equal to 0. Now it said without doing any row operations, explain why that system of linear equations is consistent. Now, time out. Remind me what it means to be consistent. Okay. What it means is you have at least one solution. Okay? If it's inconsistent, that means there's no solutions at all, period. Consistent means at least one solution. There may be more than one, but you have at least one solution. Can you tell me whether that's consistent or not? Without doing any row operations. Okay, therefore, I know at least one solution of this. x1 equals 0, x2 equals 0, x3 equals 0. That guarantees that every one of these is equal to 0. And that's true. We call this a homogeneous system in that all three of your constants at the end are equal to 0. It's a homogeneous system and guaranteed to have at least one solution. That is your 0, 0, 0. We call it the trivial solution, but it works. Okay? Now, the second thing in this block takes I'm going to do it the cheap and easy way, okay? It takes those three equations, but adds another variable to it. Plus 2x4 is equal to 0. The second equation, minus 3x4 is equal to 0. And the third equation, plus 13x4. Okay? The following system has more variables than equations. Why does it have an infinite number of solutions? Number one, you know the trivial solution will work. x1 equals 0, x2 equals 0, x3 equals 0, and x4 is equal to 0. You know it will because it's a homogeneous system. But what it says is, how can you tell it has an infinite number of solutions? Well, you know it has at least one, and then anytime you have more equations than you have, more variables than you have equations, you're guaranteed that that's going to be an infinite number of solutions. Okay? That's all you need to know on that. Now, let's get back to where we were. Those are just sort of discovery things. We'll see the results of those a little bit later. I can't remember. Let's change that. The next example demonstrates how Gaussian elimination can be used to solve a system with infinitely many solutions. Okay? So here we have 2x1 plus 4x2 minus 2x3 is equal to 0. 3x1 plus 5x2, is equal to 1. Man, it's just about this time. I think I finally figured it out. I think my blood sugar gets low by this time in the morning because I ate breakfast pretty early this morning. I haven't had a thing since. And always in this class, pretty much at this point, I just suddenly lose it, you know, and I think my blood sugar gets low. I don't know that for a fact, but I'm guessing. All right, how would you solve that system of equations? Solve. We want to know what the solution is. That's your system of equations. How do we find the solutions? Yes, turn it into a matrix. Sounds like a capital idea. Okay? Now, I hope y'all won't take offense at this, but in this course, okay, linear algebra, that's going to be a safe answer, usually, in just about anything. And I've been to several different churches. Our church does it too. They have what they call children's search, when the kids come up. Yeah, and usually either the pastor or one of the leaders or something like that gets up and talks with the kids, and they usually ask them questions. And there's always one kid, it seems like, in the class, in the group of them. If they ask a tough question and nobody knows the answer, one kid's going to say Jesus. Yeah, because that's usually a safe answer, isn't it? No one's going to gripe about that being a wrong answer, So okay. Same thing here. When I say, what do we do first? If you can't think of it, well, let's make it into a matrix. That's going to be our good, safe answer here. So let's do the matrix. You tell me what that matrix will be. 2, 4, -2, 0, 3, 5, 0, 1. All right. What's the first thing you want to happen here, and it's not automatic on this one? Yes, you want that leading number in the first row, leading non-zero number in the first row to be a 1. It's not. It's a 2. Is there any easy way we could make that a 1?
Yeah, you could subtract row 2 by row 1, or you could divide row 1 by 2.
Yes, now that is probably the safest way to do it. Divide row 1 by 2. And like we said before, sometimes it'll produce fractional coefficients. In this case, it won't, because all of them happen to be even. So that's a very nice thing to do. So let's do it. I will actually take the time to do that. And that will then give me what? You do it.
That'll be
1, 2, -1, 0. And we'll write the second row down. 3, 5, 0, 1. Next. What do we want to happen next? Once you got that leading non-zero entry in the first row to be a leading 1, what do we want to happen after that? Under it to be a 0. How do we make that happen? -3 row 1 and add it to row 2. Okay? So that becomes, we're using the first row, so write it down, 1, 2, -1, 0. And then what will the new second row be? 0, -1, 3, 1. Okay? Now, what's the next thing we want to happen? To review, we've got that to be a 1, 0 below it. Then we want the we want that to be a positive. That's a pretty easy thing to do. What do we do? No. Better than that. Multiply by -1, right? Or divide by -1. Either one I will do, which basically all it does is change your signs of everything in the row. 0 stays 0, that becomes a plus, that becomes a minus, that becomes a minus. That was pretty easy, wasn't it? Okay. Or divide by -1, either one. They both will work. So I'll write it down, row 2 minus row 2 becomes row 2. Okay? It's just that easy. Multiply by -1. Okay. Now what? You got a 1 here, 0 below it. Now you got a 1 here, and what do you want? A 0 above it. How do we make that happen? -2, row 2, plus row 1. Okay, that should do it. And what does that give you? We're using the second row, so write it down. 0, 1, -3, -1. And the new top row becomes 1, 0, 5, 2. Yep, you're right. All right, that's as far as we can go with Gauss-Jordan elimination. That is in reduced row echelon form. Now, remember, the first column stands for your x1, your second column stands for x2, the third column stands for your x3. x3 we cannot identify. So what we have to do is make this, see, we got a x1 equals something, x2 equals something, but you don't have a leading one for x3. So therefore what we do is assign it a parameter. Say x3 equal t, or any parameter you choose. So that's what we'll do. Let x3 equal t, or any other parameter you want to be. I just wouldn't use an x, okay? So then we write down what we've got here, okay? That x1 plus 5t is equal to 2, and x2 minus 3t is equal to negative 1. Okay? So this tells us that x1 equal 2 minus 5t, and this tells us that x2 is equal to 3t minus 1. So that gives us an infinite number of solutions. Okay? For instance, let t equal 0. Well, then x1 would equal to 2, x2 would equal minus 1, and x3 equals 0. Hasu said, let t equal 0, t is x3. Let t or x3 be 1, and then you would have 2 minus, that would be a, x1 would be a minus 3. This would be a positive 2, and x3 would be a 1. Any t that you want to choose there, you can come up with an ordered triplet, which is your solution. That's definitely many solutions. Okay? So they said let x1 equal 2 minus 5t. Yep. x2 equal minus 1 plus 3t. I said 3t minus 1. And x3 equal 3. I should write that. x3 equal t. Okay. Infinite number of solutions. Now, what's that? You don't have to put t. You can put any parameter you choose.
Why do you have to change x3 to anything?
You really don't have to, except we count x3 as a variable, okay? And the t is a parameter, okay? The t you can let be anything you want to, and once you got that, then you have your ordered triplet x1, x2, x3, okay? And you're right, the t is going to be the same as x3, so why change the name? It's just that when you write it down, all of them are depending on the same parameter t. And those are your variables, those are parameters. It's just the name. That really is all it is. If you wrote it the other way, it would make it look, and it is true, that x1 depends on x3, and x2 depends on x3, and x3, of course, is itself. But when you write it down as a parameter, it doesn't give preference to any one over the other. Kind of. I mean, even though you know it's exactly what you choose your t to be. It just makes for a little more convenient way to write your answer without having your variable in the answer. That's all it's doing. Now, I think we'll have an example later where we might have 2 or more parameters, okay? And if that's the case, then just to have, usually you do S and T or whatever, you can do anything, just you usually don't use the same letter you did before. And then your X3 might be S and your S4T, and then your X1 and X2 depend both on S and T. And you might say, well, why didn't you leave the X's in there? Well, to give your answers strictly in terms of things other than themselves, I guess is. I ask myself the same question. I've never come up with a good answer. It's just the books always do it this way. Okay? And how far along in calculus are you? You've finished all 3. Remember when you had parametric equations? That's what you had. You didn't put the same variable back into it. You used a parameter for it. Now, every now and then you could do that, but some equations you couldn't. And so it's just more convenient to have a separate parameter. Okay. These you certainly could have done that. All right. Good question. Now, sorry I don't have any better answer for you than that. Except that's how they do it. Okay. Now, we already hit on this in that discovery, homogeneous systems of linear equations. Anytime you have a system, and this is the most generic form, A11x1 plus A12x2 plus A13x3 plus ... plus A1nxn is equal to 0. A21x1 plus A22x2 plus A23x3 plus ... plus A2nxn equals 0. Okay? In other words, you have long O, however big n is, system of equations, that many variables. You have these, but all your answers are zeros. You know that system of equation has at least one real answer, one root, and that's the trivial solution. X1 equals 0, X2 equals 0, X3 equals 0, X4 equals 0, all the way up to X of n. All of them equal to each other, and they're all equal to 0. That's going to be a solution. Then you may be able to get more solutions out of it, possibly, okay? But you know you've got at least one, okay? These are called homogeneous systems. You keep on going down here and here and here and here and here until you get A sub, do they do M? Yeah, M1 X1 plus A M2, ugly M, M2 X2 plus A M3 X3 plus ... down to A sub M n X of n is equal to 0. All of those terms, the summation of all is equal to 0. Like I said, guaranteed one solution, every one at X equals 0, that's a trivial solution. If it's a homogeneous system where all those are equal to 0, you know for every variable equals 0, it will give you a solution. Then the rest of them, you see if there are any other solutions beyond that, what we call the non-trivial solutions. Okay? So, let's do those. Well, before I do anything else, let me just pause this. All right. So this is what we mean by a homogeneous system of equations. Let's take a look and solve one of them. I think you'll find the solution turns out being pretty simple too. Now, x1 minus x2 plus 3x3 is equal to 0. To be homogeneous, they all have to be. 2x1 plus x2 plus 3x3 equals 0. There's our system of equations. 2 equations, 3 unknowns. Okay? How would we proceed? Right into the matrix. You got it. How would that go? 1, negative 1, 3, 0, 2, 1, 3, 0. Now, what's the first thing you want to happen in that system of equations, that matrix now? A 1 in the upper left. You got it. It came with it. Good. And what's the next thing you want to happen?
You want a 2 at the, not 2, you want a 0 at the number below it.
And how would you get that?
You, negative 2R1 plus R2.
Got it. Okay. So our next equivalent matrix, since we're using the first row, write it down. 1, negative 1, 3, 0. What's our new second row?
2.
No,
0.
0.
Then 3.
3. Negative 3.
And then 0.
0. Yeah, I like that last one. That's easy, isn't it? Okay. Now what? And how do you make that happen? By 3. So that'll be a 1 and that'll be a minus 1. Okay? So I'll write that down again. So row 2 divided by 3 is a new row 2. Okay? So we have a 1 minus 1, 3, 0, and a 0, 1, minus 1, 0. What's the next thing we want to happen? Right, you got this one, 0 below it, this one, now you want a 0 above it. And how do you make that happen?
Negative R1.
Okay, no, I don't think so.
Pretty much.
Yeah, row 1 plus row 2. Okay, that will do it without messing up your other leading 1s or 0s. So what do you get? The new row, actually I should say row 2 plus row 1, it doesn't really matter. Your second row stays the same, 0, 1, negative 1, 0. What's your top row become? 1. Zero. Okay. Now, what would you do now?
You get that, change that negative 1 to a 0.
Okay. You've taken it as far as you can. Leading 1 here, leading non-zero entry here is 1, 0 below it. Leading non-zero entry here is a 1, 0 above it. You don't have anything else to do. So now, this is where if you have a column without a leading 1 in it, and it doesn't have to be at the end, it can be in the middle here somewhere. Every column without a leading 1, you let that column represent your parameter, what you want to use. What symbol? What's that? T. Why not? That's their favorite. So let x3 equal t. And now we write down what the others are.
So you said you make the row with the 0 and mark the parameter.
Okay. Every row you've got here that's not an all zero row, you could have an all zero row. Any row you got that's not an all zero, each of those rows has to start with a leading one with zeros below. Leading one, zeros below. Any column you have that doesn't have a leading one in it, that one, that variable you let represent a parameter. Okay? Because you can solve this for x1. You can solve this one for x2. You can't do anything. You don't have a leading one for x3. You can't go in and start messing with this one, because if you mess with this one, you're going to mess with that. So then you won't have a leading one. So once you've done this and all your rows have leading ones, unless you have all zero row, then you're done with Gauss-Jordan elimination. But now we go back and plug in using parameters. Okay? So then what could you tell me here? X1 plus 2t is equal to 0. X2 equals 0, and x3 equal t. Okay, if you solve this for x1, this becomes x1 equal minus 2t, x2 equal t, and x3 equals t. There you got it. So your solution is the ordered triplet minus 2t, t, t. Okay? That's it. Plug in any t. And notice 0, 0, 0 certainly fits because that's homogeneous. It's got to. But minus 2, 1, 1, 1, that fits. 2, minus 1 fits. 1, minus 1 half fits. Or minus 1, 1 half fits. I mean, you could do an infinite number of them, but those are your infinite number of solutions, okay? And that's what it says. Solving a homogeneous system with linear coefficients, you wound up with an infinite number of solutions. X1 equal minus 2t, x2 equal t, x3 equal t. All right, that leads to theorem 1.1. I guess I'll write that on the clean page. Do you need this anymore?
No, do you want to continue though?
What's that?
Do you want to continue? It's 12, 17, you want to continue?
Oh my goodness. It is time, isn't it? Yeah. Okay. We'll start next time with theorem 1.1. Okay? Let me erase this so I'll not to count that next time. Okay. Homework exercises. We almost finished. We're that close to finishing. Do any of the odds 1 through 5, any of the odds, either 7 or 9 or both, any of the odds 11 through 17, 19 through 23, 25 to 25 to 37, try 39. It's sort of a long one, but give it a shot. Either 41 or 43 or both. And I think you could probably do 45. If you can't, if you have any questions about it, bring them to class, we'll work it. Try 47. Okay, that's a little bit different kind of thing. And 49. try 51 and try 53. And then the rest of them you can look at if you'd like. We'll finish this section pretty quickly next time and move on to 1.3. Okay. Remember, we do have class regular on Thursday. We'll have class next Tuesday. I just may be a little late. If you get here, I'm not here, don't leave. I'll get here as soon as I can. If I know I can't get here, I'll call someone and have them come and let you know. Okay, good deal.